Hey, all you cool polar bears and polar cubs. Welcome to lab number 2 for the year. This time we're going to try to determine the percentage of salt inside of a salt solution. So, some of the things that we're going to be using, we have salt solution. I have a 10 milliliter graduated cylinder. I have a watch glass. And I have a 100 milliliter beaker. We have wire gauze, a ring stand plus a ring clamp, a Bunsen burner, some beaker tongs, and a nice striker. Striker, no striking. All right, so the first thing that we're going to do is we're going to take the mass of both the beaker and the watch glass. And we found that to be 78.16. All right, now that we have that mass, I'm going to measure out about 5 milliliters of salt solution. Okay. You want to make sure that you're making this reading after you get as many of these bubbles out as possible, and that you make it to the reading of the precision. And man, am I good. It's 5 milliliters.
5 milliliters?
Holy moly. My special guest is here.
Wait a second. I don't think that's the right precision place value there.
No? Where should I take it to, Mr. Carneal?
Well, it's counting up by 0.2. So it looks like you need to go to the tenths place.
So we're going to put 5.0. Is that better?
Yeah, that's exactly right.
All right.
5.0.
Thanks, Mr. Carneal.
You're welcome.
Now we're going to pour this in so we can get the mass. Try to get as much in every drop. So we got that. Put the watch glass back on. And Mr. Carneal, what's that mass?
That mass there, 83.61 grams.
83.61 grams. All right. Now we're going to get it set up on this ring stand before we light that Bunsen burner. So I turned on the gas. And now that I got Mr. Carneal here, I feel safe because I'm not working alone in the lab.
Never.
I'm going to open the bottom of the Bunsen burner until I can start to hear the gas. Then I'm going to use the striker. Light the fire. And then I'm going to turn the oxygen. Allow it in there. And get that nice inner blue cone. Mr. Carneal, why do we use the inner blue cone?
Well, we know that the hottest part of the flame is the blue flame. So we try and get that blue flame for a nice consistent hot flame instead of that cooler orange flame.
He's right on the money there, folks. We're starting to boil, or at least heat it up. I'm going to move so that the camera can be closer so you guys can make some observations and inferences on the things that you're seeing. So as you can see, there's not really much happening right now.
Oh, I'm starting to see a little bubble in there.
We do have some bubbling going on. All right, I'm going to come back in a little bit when we have some better observations. All right, welcome back. You're going to be able to see now that it is white. and that would be the salt, right, Mr. Carneal?
That's right. All I see left, a little white residue. Not much liquid left in there at all.
Except for on the top. You see that? There's some moisture. So how do we get rid of that moisture, Mr. Carneal?
How do we get rid of the moisture?
So in order to get rid of the moisture, we're going to take the flame up, and we're going to actually go like this on the top.
You know what? I learned something new today. Guess I've never done it this way before.
See? You're never too old.
Never too old to learn something new. Look at it. Them bubbles are disappearing.
Do you see any more moisture?
Looks all clear to me.
All right. So what we're going to do is I'm going to go ahead and have Mr. Carneal turn off the gas. And then we're going to bring it down. We're going to let it cool, and we'll be back once it's cooled. All right. Welcome back. We have allowed it to cool. Here it is. I'm going to put it onto the balance and get a reading.
We've got 78.80 grams.
Okay, so that's after one heating. We have to heat it again because we're looking for constant mass. So I'm going to put it up here, and Mr. Carneal is going to light that fire. And then we will get going again. We're going to, again, blue flame before you even get close to that wire gauze.
Mr. Renee, why are we heating this up again?
Well, we're looking for constant mass because if we don't have constant mass, we don't know if we actually got rid of all the water. So we're heating it up. We'll probably heat it up for about 3-4 minutes. And we're looking for a mass that's really close, kind of like the gum lab.
Okay. So we're just trying to make sure that we get rid of all the water to be as accurate and precise as possible.
Yeah.
Nice.
So we can repeat it. All right. We've been heating it up for about 3-4 minutes. So I'm going to go ahead and take it down. Mr. Carneal is going to turn that gas off so I don't catch myself on fire. And then we'll let it cool. Now, one of the things that I always was interested in was like in science, you put your hand out on the counter and you had this like print left. Mr. Carneal, do you know why that happens?
You know, I think it has something to do with the humidity and the moisture on your hands.
A little bit, but it also has to do with the fact that these countertops, they take the heat out of your hands. So they literally like suck it out. That's why your hand's always cold.
So you're saying it's a really good conductor of heat and energy.
Yeah, it's great for conducting heat and energy, which is why we put that beaker right there to cool off.
Nice.
All right, welcome back. Oh, forgot to put those goggles down. So we're going to get the last mass reading.
Hopefully all that water's out of there.
Oh, looks like we're having a little technical difficulty. All right, don't breathe too heavy.
Okay. 78.80. Same thing as the one before.
Wow, Mr. Carneal, we're good.
No, right here.
Oh, yeah.
Yeah.
My bad.
Boom.
Oh, safety first. All right, everybody. Hey, it was great having you in the lab, and we'll see you soon.